Welcome to this video. Today in this video, we will learn about the surface area of a combination of solids. In the previous session, you have learned about the surface area of all solid figures such as cuboid, cube, cylinder, cone, sphere and hemisphere. If you are asked of the figures formed by the combination of these solid figures, can you find the curved surface area and the total surface area? Let's discuss about it. You all must be familiar with an ice cream cone because all children like it. Look at this ice cream cone carefully and identify the combination of figures that make the cone. Let's draw its shape. By looking at it, we can see that it is formed by combining two figures, a hemisphere and a cone, where the top part of the ice cream cone is a hemisphere and the bottom part is a cone. Now, if we have to put a paper cover on this ice cream cone, how much paper will we need? Correct. For this, we will have to find the curved surface area of the ice cream. Since we have to find the curved surface area of a figure that is formed by the combination of two or more figures, we will add the curved surface area of a hemisphere 2 pi r square and the curved surface area of a cone pi rl. We obtain the curved surface area of an ice cream cone as pi r within bracket 2r plus l. You can see that the paper used to pack the ice cream cone will be equal to the total curved surface area of the cone. Similarly, we can find the curved surface area and the total surface area of a figure formed by combining any two or more figures. Today in this video, we learned to find the surface area of a figure formed by the combination of solids. In the next video, we will see some interesting examples based on it. Welcome to this video. In the previous video, we learned about the surface area of a figure formed by the combination of solids. Today in this video, we will see some examples based on it. The general manager of a private limited company wants to put wallpaper on the outer walls of the company's warehouse, for which he contacts an engineer. We want to put wallpapers of dimension 50 cm square on the outer walls of the company's warehouse. So can you tell how many wallpapers will we need in total? Sure. But before that, can you tell me about the shape and the measurement of the warehouse? The company's warehouse is in the form of a combination of a cylinder and a cone, whose heights are 100 meters and 40 meters respectively, and the radius of the base of the both is 30 meters. Okay, I'll tell you in some time. The engineer first finds the total area of a wallpaper. What will the engineer have to do to find the total number of wallpapers? Good. For this, the total outer area of the warehouse is to be divided by the area of one wallpaper. Now, with the size and the measurement mentioned, the engineer makes a rough picture of the warehouse. He sees that the wallpaper will not be placed on the base of the warehouse and the part where the cone and the cylinder meet. So, in order to find the area of the wallpaper to be applied, he has to find the curved surface area of the cone and the cylinder. But to find the curved surface area of the cone, it is also necessary to know its slant height. Can you help the engineer find the slant height? Correct! The slant height can be found by substituting all the values in this formula. Now, to apply the wallpaper, let us quickly find out the total area of the outer walls of the warehouse, which is equal to the curved surface area of the cone and the cylinder in the warehouse. Can you give the formula for the surface area of the cone and the cylinder? Brilliant! Now let's solve by substituting all the values. From this, we get to know that the total area of the outer walls on which the wallpaper is to be applied is 23,550 square meters. Now we will divide this area by the area of a wallpaper so that we get the total number of wallpapers needed. The engineer immediately calls the general manager and tells that he will need a total of 94,200 wallpapers. With this example, we saw how our daily life problems based on solids can be solved. Welcome to this video. In the previous video, we solved an example based on the surface area of a combination of solids. Today in this video, we will see another example based on the area of a combination of solids. The length of a pencil is 23 centimeters and the radius is 3 centimeters and the height of the conical part of the pencil is 4 centimeters. Now can you find what will be the curved surface area of the pencil? To solve the question, pause the video and then match your answer. By looking at the pencil, we cannot tell which figure it is. But if we look at the figure carefully, we can say that its front part is a cone, middle part is a cylinder, and the lower part is a hemisphere. Where the height of the conical part of the pencil is 4 centimeters, radius is 3 centimeters, the length of the cylinder is 16 centimeters, and the radius of the hemisphere is 3 centimeters. Thus, we can say that this entire figure is made up of a combination of 3 figures. Now, if we sum the curved surface area of these 3 figures, then we will get the curved surface area of the pencil. We know the height and the radius of the cone, but for the surface area, we need to find the measurement of the slant height L of the cone. So, can you tell what will be the slant height of the cone? We can find the slant height of the cone with this formula, which we get as 5 centimeters. By substituting the value of the radius r, the height h, and the slant height L in this formula, and upon solving, the curved surface area of the figure is obtained as 405.42 square centimeters. So we can say that the curved surface area of the pencil is 405.42 square centimeters. In this video, we saw an example based on the area of solid shapes.